We now discuss the solution of a problem from the section Linear Algebra that appeared in the CSIR National Eligibility Test held in December 2023. The problem is on the invertibility of matrices in the given context. This question is from part C and it is a multiple select question. There can be more than one answer. It carries 4.75 marks and its question ID is 704073. The given problem is, let X and Y be two n by n real matrices such that xy is equal to x square plus x plus I. Which of the following statements are necessarily true? So, we have two n by n real matrices x and y satisfying xy is equal to x square plus x plus I. Then, which of the following statements are necessarily true? Option 1. X is invertible. Option 2. X plus I is invertible. Option 3. xy is equal to yx. That is x and y commute. Option 4. Y is invertible. Right. Let's now discuss the solution of the problem in detail. We have n by n real matrices xy satisfying xy is equal to x square plus x plus I. Right. In such a situation, is x invertible? That's the question. Is it always x invertible? So, the first option we consider, x is invertible, option 1. Now, we have xy is equal to x square plus x plus I. X and y satisfy this equation. Now, we can write down xy minus x square minus x is equal to I. Take the prefactor capital X and write it as the product of two factors, x into y minus x minus I is equal to I. That is the product of two matrices is I, and they both are n by n matrices. Therefore, x is the inverse of y minus x minus I, or y minus x minus I, or x is the inverse of y minus x minus I, or y minus x minus I is the inverse of x. So, this implies x is invertible. So, thus, our option 1 is true always. That is the right. Now, let us take the next option, option 3. xy is equal to yx. That means x and y satisfying such a relation, will they commute? Yes. We have xy is equal to x square plus x plus I. What is x? X is invertible. Therefore, pre-multiply both sides by x inverse. Then you will get y is equal to x inverse multiplied by x square plus x plus I. Because the x inverse exists because x is invertible. Now multiply now. That implies y is equal to x square multiplied by x inverse multiplied by x square is x. X inverse multiplied by x plus I. X inverse multiplied by I plus x inverse. Now post multiply by x in order to get yx. So you will get yx is equal to x plus I plus x inverse multiplied by x. Then x into x, x square, x into I, x into x inverse I, which is nothing but xy. Thus, yx is equal to xy. In other words, xy is equal to yx. Thus, x and y commute. Yes. When x and y are chosen satisfying such a relation, x and y commute. Option 3 is true. Agreed. Let's now see what happens for the other options in the next slide. Right. We have x and y satisfying such a relation. 2. Option 2. In such a case, x plus I, is it invertible? That's the question. Now, the answer is not always. If it is not always, you show me an instance where this does not happen. So, look for a counter example, in other words. Right. xy is equal to x square plus x plus I. This is what we have. Now, xy minus x square is equal to x plus 1. Take x common. X into y minus x is equal to x plus I. Agreed. If you take y is equal to x, then this becomes 0. And x is equal to minus I, this becomes 0. So combine both. If you take y is equal to x is equal to minus I, then this is satisfied. That means this relation is also satisfied. So this is satisfied when x is equal to y is equal to minus I. And when you take x is equal to y is equal to minus I, this relation is obviously satisfied. But in such a case, what is x? X is equal to minus I. Therefore, x plus I is 0. Therefore, x plus I is not invertible, because 0 is not invertible. The matrix 0 is not invertible. Right. So, therefore, x plus I is not invertible in such a case. That means in this particular case, this is not possible. So that means x plus I is invertible is not true. Is not true. It fails in some cases. Right. This shows that x plus I is not invertible for all choice of xy. And in such a case, in such a choice, this fails. Therefore, this is not always true. Therefore, option 2 is not true. Agreed. Let's go to the next option, the leftover option. That is the option 4. So, x and y are n by n matrices satisfying the relation 1, xy is equal to x square plus x plus I. In such a case, is y invertible? Now, we look for a counter example, and we look for matrices x and y satisfying the relation 1 where y is not invertible. This we will do it in the case of when n is equal to 2. That means they are 2 by 2 matrices. So let n is equal to 2 and take this x with a matrix whose characteristic equation is x square plus x plus 1 is equal to 0. How do we get this one? Look at the relation 1. On the right hand side you have x square plus x plus I. And for a 2 by 2 matrix, suppose x is a 2 by 2 matrix, x square plus x plus I means x is a matrix whose characteristic equation is x square plus x plus 1. If this is the case, then by Cayley-Hamilton theorem it satisfies. Then thereby capital X square plus capital X plus I will be equal to 0. So that is why we have considered n is equal to 2. And you consider x is a matrix whose characteristic equation is x square plus x plus 1 is equal to 0. Then capital X square plus capital X plus capital I is equal to 0. This becomes 0. This becomes 0. That is, what kind of a capital X it is? When the characteristic equation is x square plus x plus 1 is equal to 0, in a 2 by 2 case, the trace of x is minus of the coefficient of small x, that is minus 1, and the determinant is the constant term, that is 1. So determinant of x is 1. So choose a 2 by 2 matrix whose trace is minus 1 and determinant is 1. So capital X is equal to get the trace 0 minus 1 we have put, and thus we got a trace minus 1, and the determinant is 0 1 minus 1 minus 1. If you put, you will get the determinant is 1. Then in such a choice of capital X, take y is equal to 0. So for this choice x, capital X, the right hand becomes 0, and for y is equal to 0 0 0 matrix, xy becomes 0. Thus is a pair of 2 by 2 matrices which satisfy the relation 1. In such a case, is y invertible? No, y is the 0 matrix. So y is not invertible. So just because they satisfy this relation that y is invertible, it's not always. So this pair satisfies the relation 1, but y is not invertible because y is the 0 matrix. So therefore the statement given in option 4 is not always true. Therefore option 4 is not true. Right. We have already shown option 1 and option 3 are true, and option 2 and option 4 are false. Therefore the answer to this question is option 1 and option 3. I am sorry. Option 1, we have shown option 1 and option 3 are true, and option 2 and option 4 are false. The answer to this question is option 1 and option 3. That is the detailed discussion of the solution of this problem. This is definitely an interesting question on invertibility. Right. I am sure that you have understood the solution of this problem, and you have been watching my videos related to NET examination, IIT JEE main examination, TS set, AP set, etc. examinations. I am definitely sure that you like my videos. If you like, register your liking by giving a thumbs up in the channel, and share my videos with your friends, colleagues and relatives. If you have not already subscribed my channel, please subscribe and request all your colleagues, friends who are interested in mathematics to subscribe my channel. I wish you all the best. Thank you.